Hello and welcome back to the lecture of time series econometrics. In this lecture, we are going to cover a very important topic called autoregressive moving average model, or in short, ARMA model. Now, as the name suggests, ARMA is basically a combination of AR and MA, which is autoregressive as well as a moving average model. Now, if I have a ARMA model of order P and Q, I can basically sort of consider it as a combination of AR model of order P and a MA model of order Q. Now, as a basic ARMA model, we can consider ARMA model of order 1, 1, which is basically a combination of AR model of order 1 and a MA model of order 1. Now, why do we need to think of a separate model like ARMA, which is basically a combination of already discussed model AR and MA? Now, there is some utility of that, and the utility is that the ARMA model is much more encompassing than only a AR model or a only MA model. So, the thing about ARMA model is that you can actually create time series models using like your the conceptual framework, which would be more close to reality. And in fact, using ARMA model, you can create lot of time series model which are which will somewhat reflect the real scenario. Now, to basically mathematically write a ARMA model of 1 1, so let us just try to write it down here. So ARMA 1 1, which is a basic unit. 1 1 is a basic unit of ARMA. We can write it as using the previous notations. Yt is equal to phi yt minus 1 plus et theta et minus 1. So if you note it, so this component is basically this AR component. This component is basically the MA component, and then we have this error term, right? So in the first component, the phi yt minus 1 is basically giving us actual observation of the past period, and theta, like we of course adjust the past period value with a weight of phi, whereas the theta epsilon t minus 1 is basically giving us the past period error value, and when we multiply it with theta, so it gives us a weighted past period error value. So we basically include both the past period observation as well as the past period error in the ARMA 1 1 model, right? I mean, you can have ARMA M N model or PQ model. So it just simply you have to consider a ARP model and a MAQ model, and you can extend your the YT values or ET values accordingly. Okay. Now, all right. So that's all right. Now, if we have to sort of understand how it really works, so we'll take an example. And if you remember, previously we spoke about the example of a ice cream demand. Say you all have come back to the campus post the lockdown, and once you come back, we have created a, say, free ice cream for everyone. Sort of, we're providing that free ice cream for everyone. We've created a supply chain for that. And suppose there is only one seller in our campus, and the seller has to sort of get a sense of how much is going to be the demand. And so that is basically we will try to understand using this ARMA 1 1 model, right? Ice cream seller. So this is now ice cream seller's problem. Ice cream sellers, say let's say demand estimation. Ice cream sellers demand estimation. So what this ice cream seller is going to do now, he will consider two things. One is that the people who have purchased in the previous period, so ice cream seller would consider that since these people actually prefer to have ice cream, a fraction of them are going to continue buying ice cream in this period also, right? So if the past period ice cream demand was so basically he's trying to estimate YT, and if the past period demand was YT minus 1, so all he has to do, he has to consider a weight of phi and say that all right, so this phi percentage of the past period demand is going to be reflected in this period demand. Now, you remember that in the previous model we actually talked about the error. So the error, we used a white noise. We actually gave you the white noise to kind of construct the MA component. You just simply have to take a moving average of that, the error terms. But here, the ice cream seller, he doesn't have that readily available error term in his hand. Nobody has given him the white noise to construct this model. All he can do is he can just observe what is happening, and using these observations, he can actually decide what value to put or how to model the error term. So, which is basically here, the observed error term is here is a epsilon t minus 1. Now, the epsilon t minus 1 term is going to come from the real observations. So, what are the real observations here? So, here what we can get, what the ice cream seller can get is, he can, let me use a different color actually, he can definitely get the past period actual demand, and he used the model to predict the past period demand, and where he used, say, y t minus 1 predicted. So, yt minus 1 hat is basically going to give us the predicted value of the past period. So, he used the model to actually predict this yt minus 1, and this difference is going to give him the et minus epsilon t minus 1, right? So, he is actually getting this error term from the past period. Okay, so now he has both the components in his model, and of course he will have another error term from the present period, which is epsilon t, and definitely he has no clue about the epsilon t because this process has not happened yet, right? So when the process has not happened yet, he doesn't know epsilon t, right? So all he can do is he can create this model, and then he can predict the model. He can, have a y hat t, where we can actually get the value of the predicted yt for this present period, but we'll talk about it later. So that's basically the ARMA 1-1 model. Now you can have ARMA, as we said, that the ice cream seller can decide to actually take two past period demand, right? So he can take yt minus 1 and yt minus 2. So he can have two different weights like phi 1 and phi 2. Similarly, he can take like 2 or 3 error terms. So et minus 1, et minus 2, and he can have the corresponding weights theta 1, theta 2, and he can create a better, model with more components. So that way we can actually conceive how the ARMA model is going to look like. So this is basically the presentation of ARMA 1-1 model. Now, in the next lecture, we're going to talk a little bit about the properties of ARMA 1-1 model.